Dr. Nektarios Karanicas is an Associate Professor of Health, Safety and Environment at the Queensland University of Technology. Having previously served as an aeronautical engineer with the Hellenic Air Force for 18 years, Dr. Karanicas has gained much experience in maintenance, quality management, accident prevention and air investigations. He also launched the International Cross-Industry Safety Conference in 2016 to provide a forum for ideas to make safer work environments. Dr. Karanicas also holds an MSc in Human Factors and Safety Assessment in Aeronautics. He'll discuss the biofuel and wind energy sectors and how workers can be kept safe and protected as they build our energy future.
Hello, everyone. My presentation tonight, wherever you're joining from, it's not a topic we discuss when it comes to sustainability. And it is based on 2 reviews we did recently with students from QUT regarding the worker health in the wind energy and the biofuel sectors, who are 2 of the sectors in the spearhead regarding environmental protection and sustainability. Nevertheless, I would like to start with some fundamentals, assuming that many of the attendees are not very aware of the topic of occupational health. So usually when we look at statistics worldwide, injury is what we listen on the news, we hear from colleagues, unsuccessful moments, of course. And 20%, less than 20%, according to ILO, it has to do with work-related fatalities. It's already a big number. What we usually forget and underestimate is that 80% of the fatalities are not due to injuries, immediate injuries. Somebody, let's say, trips over and hits his or her head, and we have there like a concussion or any other trauma. So they're because of occupational diseases. And I bet that only few of you have heard of somebody that died due to workplace-related disease. Most of the times we hear about injuries. Now, to put things into perspective and in the context, ILO estimates that 1.9 million people suffer every year fatalities due to accidents or work-related diseases. That's a huge number. But on top of those people, we have about 360 million injuries, which are non-fatal, but still affect the individuals, the families, the communities, and result in over 4 days of absence from work. Apart from the social, the individual, the family cost, there is also a huge capital here, a huge expense, 4% of the global domestic product each year, which is attributed to those injuries and diseases. And just to put some figures, this in American dollars is about 3.8 trillion each year. So work-related fatalities and diseases or non-fatal injuries are a huge problem and cost a lot at all fronts. So that's the first key message for you. Now, the next challenge is that we have 2 areas, the occupational hygiene and occupational safety. Hygiene is more about health and the long-term health effects of hazards in the workplace. Safety is more about immediate effects. So one differentiating parameter has to do with the time factor. And we usually underestimate occupational hygiene hazards because we don't see the effects immediately. We are exposed to hazardous agents. We are exposed to different chemicals or any other hazards. And because we don't die immediately, we don't feel unwell immediately, we underestimate that over time and cumulatively, those can have really detrimental effects on our health. Then we have the damage factor. In safety, when we are injured usually like we break our leg or we have bruises and wounds in specific body areas, unless it's, of course, a big accident. When it comes to occupational hygiene, we have damages on more than one tissue because the exposure to agents, our bodies exposed to those hazards, it's not something that happens locally, like only our liver or only our kidneys or heart are affected, but usually we have more than one body parts and tissues. And then it's the dose factor. When it comes to safety, we can see usually the risk. We can see the hazard. We can feel more or less that something is risky or not. When it comes to occupational hygiene, we are dealing with hazards that cannot be easily detected with the senses. There are plenty of hazards and threats in the work environment that you cannot see, that you cannot hear, and you cannot smell. So those are the two differences. And my presentation tonight will focus mostly on occupational hygiene, not that much on occupational safety. So if you see on this photo here, there are both hygiene and safety issues in this occupation. So immediately somebody would say, we might, let's say, have a fire there because you see the sparks, but maybe a few will think that the fumes emitted during the welding process, that the radiation itself emitted from the process might damage this workers' health over time. Now, how do we get knowledge about occupational hygiene? Of course, we need to understand the processes at the workplace, what agents, what hazards they produce, or what agents we use to run the process, to what degree and when those hazards become toxic, and if they become toxic, then what health effects those hazards have, then what options we have to control the risk, to mitigate the consequences, how much, of course, each of those controls costs in order to prioritize and to see the best and decide about the best combination, and of course, effective risk communication. It's highly important here because, as I said before, it's very hard for people to understand why something is hazardous if they don't sense it, which is the case in occupational hygiene. And in order to achieve all those, we have plenty of disciplines that collaborate, that come together to study the work, the processes, the hazards, the toxicity, the dose-response relationships, and give to us the knowledge we need to avoid, to prevent, to mitigate those conditions. So that's about the fundamentals, and I will finish this first part by mentioning that what we're trying to do in occupational hygiene is to control everything at the source. So as you can see on the left of this graph. Now, if we do our best to control things at the source and still we have emissions, then we try to control things across the air path. And if this is not possible, meaning that we still have some unacceptable risk there, then we focus on the worker. So we provide to the worker personal protective equipment. Nevertheless, the main message also here is that we are very much interested in preventing things as early as possible. So we focus at the source. Now, getting into the first topic about aviation fuels, we published this review about a year ago. There might be some updates since then, but I don't expect that the picture has dramatically changed. So what's going on? We have been using conventional aviation fuels for many decades now, and we're talking about a huge demand. about 300 million tons annually and increasing. Of course, we can exclude the COVID-19 pandemic period where we didn't have that much traffic, but now we are recovering. And we have over 2 million people who work in the aviation industry and are exposed to those aviation fuels. So why have we been using those kerosene-based conventional fuels? Because of availability. They have great physical and chemical properties that provide excellent performance for aircraft. The problem is that they contain hundreds of compounds, hydrocarbon. Many of them are toxic, like benzene. And the toxicity of aviation fuels and the methods that we use to refuel aircraft and to handle fuel in general have been debated for quite some years now, but we still, of course, use them. So using conventional aviation fuels is not only an environmental issue, it is also a worker health issue. And not only because we might have communities that are affected, but those are not exposed to high doses of aviation fuels and fumes as workers do. So what effects do we know that aviation fuels have on humans? If we're talking about accidental ingestion, somebody can feel different effects, symptoms like vomiting, restlessness, coughing. And when we're talking about prolonged exposure from any route, so we're talking also about skin contact or inhaling, which is the most usual route of exposure. We're talking about effects like dermal irritation and damage, and even damages to DNA. Those are based on scientific research and papers, not opinions. In occupational hygiene, we apply exact science. We don't just debate. We also have animal studies to complement the effects that we have observed in humans. And more or less, those are aligned. Unfortunately, they are the same, more or less, with what we have found in humans and include liver damage, immune system problems, neurological performance problems, hearing impairment, dermatitis, and so on. Now, the new era, we say we need sustainable aviation fuels. I agree with everyone. Let's go ahead. We need to protect our environment to protect our future. What are those? So biofuels and synthetic fuels, they were first introduced to reduce the carbon footprint. We know, I guess, about that. But at the same time, of course, we have to ensure that they meet performance requirements, meaning that the aircraft will fly from A to B and with the same, let's say, reliability and about in the same time, the same performance and so on. Now, at this point, most of them are usually blended. So we have conventional and biofuel blends that we put in aircraft. They are a safer alternative, meaning safer from the perspective of fuels means, for example, they're not the same inflammable, but they have higher production costs. So this number here, the fourfold, it is based on estimations about 3-4 years ago. Maybe the situation has improved and the cost has decreased. Nevertheless, this higher cost and also lower productivity of biofuels has led to a delay of their expansion. Nevertheless, they're still chemicals, they're complex substances. They have non-biological origins like the conventional aviation fuel, but also biological origins when they are produced. And the problem is that we don't know that much about whether those sustainable aviation fuels, biofuels, are better for worker health or community health. So we know we're better for the environment. We know that they can meet the requirements of aircraft performance. At this point, once more, using them blended with conventional fuels. But we have indications that biofuels might be still genotoxic. However, they're not as bad as conventional fuels, still not innocent. Now, when comparing sustainable conventional aviation fuels, we don't have any studies with humans because it's a new type of fuel. And as I said before, the exposure needs time to yield any effects, to do epidemiological studies. So when it comes to rabbits, similar level of skin irritation, not much improvement. Another study with rats and rabbits, similar effects again. And when it comes to mice, immunotoxicity was also found in sustainable aviation fuels. Nevertheless, there's some good news in some studies with animals. Inhalation poses no hearing loss risk. So we don't have hydrocarbons that actually, let's say, magnify, accelerate the effects of hearing loss. Delmer irritation levels were lower in some rats when we have dilution of irritant compounds, and we didn't have any signs on rats on genotoxicity and mutagenicity. So a mixture of results. So research on effect in sustainable aviation fuels is restricted to animals so far. So it's always debatable in science whether we can have conclusive results about humans when studying animals, but of course you can understand the ethics of 2022 do not allow us to experiment with humans. Nevertheless, we have limited and not, let's say, very credible evidence that we have a significant reduction in human health exposure when comparing sustainable fuels with conventional fuels. We still have hydrocarbons, which we know it's an occupational exposure risk. And of course, we need more studies for long-term and short-term harmful effects, including, of course, any combinations of effects when we have other hazardous agents and chemical substances in the environment. Nevertheless, we need to live with the challenges we have, whether it's conventional or alternative. It's not an easy equation to solve. Now, the second half is about the wind energy, based on a paper, again, that we published about a year ago. So what happens is that wind energy is very rapidly growing. And this is due to many factors, as you can see on the slide. The technology, support from regulators and legislation. We have investors and also the communities. The public really supports sustainable energy, including wind energy. The thing is that over time, as we gain more knowledge, as we advance our technology, the wind turbines become bigger and more complex, technical complex, meaning that we need to maintain them more frequently or with more sophisticated ways. And it is predicted, that was a prediction about 3 years ago, that they will have the second largest impact on occupational health and safety, worker health and safety, following only any risk that we might, let's say, get exposed due to nanotechnology and nanomaterials. So there is already a concern there. Now, when it comes to safety, the risks are more or less common with other industries, like falling objects or working at heights. As I said before, safety is something more visible, or the lack of safety, actually. Now, health risks during different life cycle stages can be different. So from manufacturing to installation to maintenance and decommissioning, we have different stages. So what hazards we know so far, and we have some indications that can be a problem. When it comes to noise, the studies we have to date focus very much on social communities, the communities around the wind energy farms, and whether they are annoyed or not, or this can cause problems. Now, as the wind speed increases and the wind turbines become bigger, noise exposure could exceed the limits that we have to observe according to legislation and standards. We know that in offshore wind energy, wind turbine farms, they impact worker sleep quality. And we have also studies that suggest a relationship between low frequency noise and sleep disorders or general discomfort, annoyance, impairment of hearing, and cardiovascular diseases. Exposure to a toxic substance, the epoxy resin. This mainly during the manufacturing. So we have studies about exposure to this substance, but we have no knowledge about exposure to this toxic substance along the entire life cycle of wind turbines. So what is happening in maintenance when we have wear of the surface of the turbines? What can happen over time with this substance if it's released in the environment, or when we decide to decommission the wind turbines? We don't have studies about other risks related to chemicals like welding fumes, nanomaterials, and dust. We have studies that say that we have increased physical stress and musculoskeletal disorders in offshore installations. We don't have anything for onshore installations, and we haven't yet understood very well the long-term consequences for worker health. And we have no studies at all about biological hazards, about vibration-related hazards, and any effects of the climate and weather conditions. So it's quite unexplored area. So sustainable environment solutions, indeed. I am with Adrian. I am here to support the initiative for sustainable environmental solutions to protect our future, but are they good for everyone, or how can we make them good for everyone? That's the question. So I think there's an opportunity there for healthy sustainability, not just sustainability because we have the technology, let's go ahead, and without a good understanding of the risks that any change in the, let's say, process, any change regarding material, the combination of different factors in the work environment, how much risk impose on workers. I don't think that anyone here that listens to this presentation or will listen to the recording would advocate, yes, let's save the environment, but let the workers die. So occupational hygiene is grounded in science and engineering. We don't talk about perceptions, about political debates, about what we believe. We're talking about exact science. And we focus, of course, on the source, how we can eliminate or control all types of hazards, chemical, physical, and biological. We need to be preventative. We want to focus on the design of the work environment, and not the worker. When it comes to protect the worker with personal protective equipment, it's already late. And we need a good understanding of the hazards, and we need time to gain this understanding. Sometimes occupational hygiene cannot keep abreast with the developments in the renewable energy sector, and this can lead to detrimental consequences. I know we need to save the environment, but we must be careful. I don't say we should delay, but at least we should invest more in understanding these exposures and the possible problems. So there is a necessity there to gain good knowledge of health risks and how those risks and exposure levels can have effects or not on the health of workers, and what possible controls, what mitigation measures we can have. Nevertheless, I will finish my presentation with the challenges and problems. Actually, getting back to the very first slide, we underestimate that the occupational hygiene problems, uncontrolled risks and hazards might manifest years, decades later, and we don't really take them seriously always. We have also personal lifestyles and social conditions that add to this problem, and similar illnesses can be attributed to those conditions, and our minds do not also go to the effects of occupation. Even the doctors, the GPs, the specialists might not be aware of the kind of work somebody does, or if they know what this work entails in terms of occupational exposures. And the fact that we don't have much data, we don't have really a robust evidence base for the renewable energy sector regarding health hazards might generate this false impression that we're safe and we're healthy. And we might be, we might not be. So remember this, that many hazards cannot be seen, heard, felt, or smelled. Thanks very much for listening.